Okay. So this is my horizontal alignment. Okay. And I'll call this 10 plus 0, 0. And here's my PC and my PT. And this thing ends at, say, oh, let's just say, let's say that ends at 25 plus 0, 0. Okay. Well, this could be what my vertical alignment looks like. Where there's no correlation between these PC and PT stations and the PVC and PVT stations. I mean, my vertical alignment could just look like this. One straight grade. Okay? Now, the important part is, that for every horizontal station that you go out and stake, you know what the vertical component of that is so that they can grade it properly. But there's no correlation between the curve geometries or the curve stationings. This geometry is based on where you're starting and where you want to end up directionally, and this vertical design is being dictated by existing roadways that you're tying into and or crossing and the terrain. Does that make sense? Maybe? Sort of?
So the L is really distance travel vertically throughout that difference in station. I'm trying to envision. I know it'll probably be more clear as you get further along, but
no, but that's it. So yes, it represents. So that stationing represents the distance you travel on here. So this L distance here just represents in the curve what the distance you're traveling on the horizontal alignment is.
okay. Yeah.
Okay? Doesn't have anything to do with the curve length on the horizontal alignment. It is just a difference in stations. Because they all start at and end at the same stations. Okay? Because they're the same road. But, so what happens with this is, well, we marry this data together so that we can generate X, Y, and Z coordinates, not just X and Y coordinates, but X, Y, and Z coordinates, where Z represents the elevation of any point on that alignment. And we're on the cross section and edge of pavements and ditches and shoulders, etc. Okay. And PBI good check. All right. Before we get started, you always need to back up and find your PVC elevation. So if we know that we have 3% positive going in and 2% negative coming out, that gives us a crest curve, correct? If I've got a length of curve of 600 feet and I've got a PBI station of 4670, how do I find my PVC station? Yeah, so PVC is equal to PBI minus L over 2, or in this case, 4670 minus 600 over 2, which is going to be 300. So 4370 will be my PVC station. One thing that's missing, let's say, elevation of the PVI is 853.48. Which we can use to find the elevation of our PVC, because we know that that's 300 feet back down there, right? At what kind of percent slope?
3.
At 3%. Okay, so I can take. There are two mindsets of doing this. I can take 3% and I can multiply it by 3 stations, okay, to get my change in elevation. Or I could take 0.03, which is the decimal equivalent of 3%, and multiply it by 300. You'll probably find it easier to work with a station mindset where you keep your percentages as the whole numbers, and whenever you have a length value that's going to be basically represented by X most of the time, you think of it as in stations, which is that total length divided by 100. Okay? So that's going to give me 9 feet of change. I change 3 feet for every 100. I'm going 300 feet. So it gives me a PVC elevation 9 feet less than that, which would be 844.48. Now, if I wanted to find my first full station at 4,400, minus 4,370 is 30 feet, okay? But I want that in stations. So that's going to be 30 over 100 is going to be equal to my X value that I want to plug into here. Okay. What's G1? Well, G1 is 3. My X value is 30 over 100. Multiply that by 3. Plus 0.9. Now this spot right up here on my vertical tangent is 9/10 of a foot higher than my. If I use percentages and stations, I get minus 0.45. If I don't, then I get that. It only takes me to 5 decimal places, but it would be 0.45. You know, I just rather work with numbers that are easier to deal with.
I didn't get either of those numbers. What are you plugging in?
I'm just solving for this.
Yeah, so you're dividing the L by 100 to do the station.
So this one version says minus 2.4 minus 3 over 2 times 6 should give me minus 0.45. I'll do it again. 2.4 minus.
Oh, I mixed 2 versions. It's like
12.
Yeah.
Divide, yep. And then this one says, okay, minus 0.024 minus 0.03 over 2 times 600. And that's going to be 0. That's probably going to be And it's going to be like that every time. You have to end up with these tiny little numbers. I'd rather work with something that's closer to a whole number, closer to 1. But it'll work either way too. Use whichever format you like the best. I'm not going to manage that. All I'll say is, unless I'm asked otherwise, I'm going to stick with keeping it in that format, which is whole numbers of percentages and using stations as my X values or L values.
So either of those work?
Say again?
Either of those work?
Absolutely.
But they're like two different.
Yeah, but what's going to happen is when you come over here to x squared, so now your x squared value is going to be 30 squared as opposed to, 0.3 squared, right? So it makes up for it later on.
And the X is.
So in this case, if I'm going to 4,400, right, that's a change of 30 feet, right? Which is 30 feet is equal to 0.30 stations. So if I take this and multiply it by 0.3 stations squared, which is 0.09 times 0.45, which gives me 0.04, the negative. And if I take this one and multiply it by 30 squared, which is 900 times 0.00045 times, oh, guess what? That is equal to minus 0.04 also. So that is what the vertical drop is from the vertical tangent line down to the profile on the curve. It's going to drop from this position that was 900 higher. Now you're going to subtract that is 0.5. So what's my elevation on this thing? It's $845.34. 844.48 plus 0.9 minus 0.04. And you would do that for every other desired station on there. You're plugging in X as the difference in stationing from the station that you're solving for to back to the PVC.